Okay, so we're going to simply isolate now this purple region, this kth block in the stack above the ij subinterval of your xy plane. Okay? The dimensions of that stack are delta y ij by delta xi by delta z ijk. Again, you're in the xi strip, so that the width of that strip is delta xi. You're in the yij subinterval of that strip, and it has width delta yij. And you're on the kth block in this stack, and that's going to have width delta z ijk, just like you have delta z ij0, delta z ij1, etc. It's going to be delta z ijk. Okay? So that's the ijk increment with sample point xi star, yj star, zijk star. And it has volume, what? Well, it's rectangular solid, length times width times altitude. So it has volume delta xi times delta yij times delta zijk. So the total volume within this sphere is the sum of all these volumes. So what do we do? Well, the first thing we can do is we can sum this stack. Okay? So we sum over k, from k equal 1 to p. Now I say p, it should be pij, and it should be m sub I here, if we want to be really complete and technical, and we probably should. And then, looks like I got careless and left off my deltas. But anyhow, we sum all those, okay? Now, of course, that just gives us the height of this stack, okay? And then we multiply that by, basically by the delta yij by the xi, which is the area of this base, and we get the total area. And we sum them in this order. We sum the zijk first, and then the y's second, and the x's last. Because, of course, the subscripts for z rely on j, which is a subscript for delta y, and the delta y has a subscript I, which relies on the subscript for delta x sub I. So we have to sum them in this order, from inside to out. Now, that sum by everything you learned, or hopefully learned, and hopefully remember, but should review from first year calculus, approaches in the limit this integral. Since the delta xi's go from I equal 1 to n, that means that x is going to go from negative a to a. So we're going to integrate from negative a to a with respect to x. Now, what are we going to integrate? Well, we're going to integrate the next thing on the inside, which is the sum from j equals 1 to mi of delta yij. Well, that becomes a dy, and the limits become the limits on the partition of the y strip, of the ith strip, okay? The y partition of the ith strip. And then, so that goes from the square root, negative square root of a squared minus x squared to square root of a squared minus x squared. And then the z's, we integrate with respect to z, and the z's run from 0 to the square root of a squared minus x squared minus y squared. And we see the correlation of this limit with this expression. And this limit, of course, with this expression and this expression, or these limits, those two expressions. Okay, well, there's your volume increment. There's your volume integral, and we need to understand that. Now, there are other things we can insert into that integral, and we're going to do that next. We're going to look at, I think, the mass of a sphere, hemisphere, with a given density function.